is Flash Isaac, and I'm a teacher from the future. This is going to be a very concise and straightforward class. No drama. I trust you are going to benefit a lot. Every day, we try to do work. In fact, under work, energy, and power, we said that work done is force times perpendicular distance, the product of a force and the distance covered. And we said that energy is the ability or capacity to do work. We gave different forms of energy, and one form of energy is mechanical energy. Mechanical energy is energy an object or a body possesses due to position, due to height, that is potential energy, and energy possessed due to motion, due to speed, that is kinetic energy. Simple machines is under mechanical energy. And we said that power is the time rate of doing work. If you are able to do work in a shorter time, you have more power. If you are doing that same work at a longer time, you have less power. Now, man has limit. For example, if you give me one bag of rice, one bag of cement, I may be able to carry them. However, it will take me more stress, but I will be able to carry it. If you say, carry these 2 bags or carry 2 bags of cement together, for me, I won't be able to carry it. 2 bags of cement together, I won't be able to carry it. But some persons can carry that. If you say, okay, carry 5 bags of rice once, 10 bags of cement once, I doubt if anybody can do that. But if anyone can do any of these works I've mentioned, but you agree with me that it is not a convenient way to do work. There are devices that make work easier for us. Not just easier, they make work convenient for us. In fact, they make some things that seem impossible look easy and possible. Machines are devices with which work can be done more comfortably or more easily. Machines have various parts, or there are terms used in machine. If this guy is pushing this wheelbarrow, you are carrying the wheelbarrow with your strength, with your effort. That is the effort you are applying, which I've already mentioned. The stress, the force, that is your effort you are putting. So, now, let's say you have bags of rice here, and each of them, okay, let's say 2 bags of rice, 25 kg each. This load you are carrying, or everything here, is referred to as the load. So let's say 50 kg. In this case, we are dealing with mass. Load can also be a weight or force. If the loads are 50 kg, it means that the force here will be 50 times 10. That is 50 Newton. So this is the mass and this is the load in terms of force. If you are using a strength of 10 kg to lift the load, that is your effort. The load is good, the effort or the force is applied upward. So the effort is equals 10 Newton. Because you are pushing, effort is going up. This your effort will have to travel a distance, and this your load will also have to travel a distance. This wheelbarrow is like at rest. By the time you start pushing, once you lift this wheelbarrow up, this handle is no longer here. Let's say it's now somewhere around here as you raise the handle. So the distance between here and here is simply your effort distance. Because you are applying effort to carry the load, this effort is 10 Newton, and the distance the effort is traveling is your effort distance. So in this case, let's say 10 centimeter or 10 meters. 10 meters. As you are applying effort to lift this machine, even the load will move a distance. From here, the legs will raise up to around here, because this handle is going up, the machine is going up. So these legs are now here. This place will go up. So from original position here to this place is your load distance. Your load distance. Efficiency is simply how good a machine is, how efficient a machine is. For example, if you get a new wheelbarrow, you will notice that it is easy for you to carry. You are pushing, everything just gets so good. The handles are so firm. After some time, you see the tires are shaking. So you even need more effort to push this machine. Or you get a generator. When it is still new, it carries your load well and the sound is okay. After some years or even some months, you notice that it doesn't carry your load very well and the sound is terrible. So what has happened? The machine is no longer so efficient. So what is efficiency? It is how good a machine is in layman term, but mathematically, efficiency is the mechanical advantage you get by using the machine over velocity ratio. That is efficiency. Not just that, efficiency is also equals useful work done over total work done. It is equals work done by the load over work done by the effort. It is equals work output over work input. If I ask you to calculate the efficiency of a machine, any of this formula will work depending on what we are given. Efficiency is mechanical advantage over velocity ratio. Mechanical advantage is referred to as force ratio, while velocity ratio is referred to as distance ratio or speed ratio. Why is mechanical advantage referred to as force ratio? Because it is the ratio of force to force, force divided by force. Velocity ratio is also referred to as speed ratio or distance ratio. It is simply distance over distance. Now look at this. Mechanical advantage, MA, is load over effort. So load is the force applied by the load. Effort is the force applied by the person working on the load. So the force you are putting in the machine over the force you are overcoming is also referred to as mechanical advantage. In this case, if I ask you to calculate the mechanical advantage, you will simply say that load over effort. The load is 50 Newton and the effort is 10 Newton. So mechanical advantage is 50 over 10. That is 5. So mechanical advantage is equals 5. And the force overcome is the load, because this is the load is the force you are trying to overcome, and the force exerted is your effort, the effort you are putting in. So force overcome 50 Newton, force exerted 10 Newton. That will still give you mechanical advantage of 5. If I ask you for velocity ratio is effort distance over load distance. Effort distance is the distance traveled by the effort, and the load distance is the distance traveled by the load. In this case, if you are saying find the velocity ratio, it is simply the effort distance 10 cm or 10 meter over load distance 5 meter. That will simply give you 2. The velocity ratio does not have unit because it is the ratio of the same quantities. So we know that efficiency is mechanical advantage over velocity ratio. Mechanical advantage is the same thing as useful work done. Velocity ratio is the same thing as total work done. Mechanical advantage is the same thing as work done by the load, and velocity ratio is the same thing as work done by the effort. Because for mechanical advantage, we are dealing with the load and the effort. For velocity ratio, we are dealing with distance moved by the effort over distance moved by the load. So work done by the load is the force or the mass of the load, force on the load, and distance traveled by the load. Work done by the effort is force exerted by the effort and the distance moved by the effort. If you are asked to look for the efficiency of machine, which is usually in percent, this is mechanical advantage over velocity ratio, or you say useful work done over total work input, or you say work done by the load over work done by the effort, or you say work output over work input. Now, if work output is the same thing as work input, or mechanical advantage is the same thing as velocity ratio, efficiency will be 100%. However, efficiency is not 100%. These are the reason efficiency of machines is not equals 100%. One, the mechanical advantage is lesser than the velocity ratio, which means the velocity ratio is always bigger than the mechanical advantage. Why? For machines or for moving parts, there is likely to be wear and tear of moving parts, which is referred to as friction, which we did in the previous episode. So, because of friction, mechanical advantage is usually very low because friction affects mechanical advantage. Meanwhile, for velocity ratio, friction doesn't affect it. If you have velocity ratio here and you are plotting the graph of velocity ratio over, let's say, load, whatever, you see that it is like this. Friction is not affecting. Now, the graph of mechanical advantage over velocity ratio is something like this. It's a direct relationship. Mechanical advantage is directly proportional to velocity ratio. The graph of load and effort, let's say load, effort, is like this. They have direct relationship. But for velocity ratio, friction doesn't affect velocity ratio. So efficiency is not always 100% because mechanical advantage is always lesser than velocity ratio. And why is it lesser than velocity ratio? It is simply because friction affects mechanical advantage. Friction does not affect velocity ratio. So the work output is always lesser than the work input because friction is applied to overcome the load. That is the reason efficiency of machines not 100%. Classification of machines. Machines can be basic or general. The basic classification of machines or the basic machines are machines from which other machines are built or gotten. Levers, inclined planes, and hydraulic press are basic machines. And general classification of machines are the levers, the screw, the wheel and axle, hydraulic press. Levers are convenient to use when the load is closer to the fulcrum than the effort. You will see that very, very soon. And inclined planes are simply lengths of material placed at an angle for lifting loads. Now, anytime you are given a question under inclined plane, the velocity is 1 over the height or 1 over sine theta. You are given an inclined plane, you are given angle 30 degrees. The velocity ratio is 1 over sine 30 degrees. That is 1 over 0.5. That is how to find the velocity ratio of inclined planes. Now, levers are classified into first class, second class, and third class levers. Remember, machines we have the load, the effort, and the fulcrum. Now, what is fulcrum? If you take a look at wheelbarrow, the load is what I put inside the wheelbarrow. The effort is your strength used in carrying the load. The fulcrum is that pivot. That is holding the machine. For example, for a wheelbarrow, the pivot is the tire. That is what is keeping the machine moving. Every machine will have a pivot. Now for scissors, something like this, scissors, handle. So this is where your effort is being applied. What you are cutting is here. That is the load. So this part, moving part or the pivot, is referred to as the fulcrum. So when you hear fulcrum, you should know what we are talking about. For the first class levers, the fulcrum is between the effort and the load, which means if you have something like this pivot is at the middle, then the effort is here and the load is here. For second class levers, the load is at the middle, which means here you have load, then the fulcrum is at the end. Here you have the pivot, the effort is here. For third class levers, the effort is at the middle, so which means you have the effort here, then the fulcrum, the pivot is here, and the load is here. Now, for first class lever or levers, you see what I did? EFL. F is at the middle. For second class levers, F is at the end. For third class lever, F is at the beginning. Now, for first class levers, load is nearer to the fulcrum. For second class lever, load is nearer to the fulcrum. For third class lever, effort is nearer the fulcrum. I don't know how this is going to help you or how it's going to change the price of garri in the market, but just take note of that. For first class lever, the fulcrum is at the middle and it is between the effort and the load. Second class, load is at the middle, so the load is between the effort and the fulcrum. For third class, effort is at the middle, effort is between the load and the fulcrum. Now look at examples. For scissors, you see that if you are cutting like this, the fulcrum is at the middle, the load is at the end of the scissors, and the effort is applied at the handle of the scissors. Similarly, pliers, crowbar, pincers, claw hammer, seesaw, and common balance. These are examples of first class levers. For second class levers, wheelbarrow. You see, as you are pushing the wheelbarrow, your effort is here, you are carrying, the load is inside the wheelbarrow, then the fulcrum, the tire, is at the end. So wheelbarrow, bottle opener, nut cracker, they are examples of second class lever. And for third class levers, we have the tongs, the table knife, the load is at the end, the fishing rod, and the forearm of a man. That is it for levers. And pulleys, they are wheel with a groom rim for passage of a rope. Now you see something round like tire, you put belts or wheels around to push. All these are pulleys. And pulley can be the block and tackle system, it can be the Archimedean pulling, and it can be differential or Weston pulling. Block and tackle system has one string and many pulleys. So there are different pulleys, but one string is holding all of them. In that case, the velocity ratio is 1. When you have one string, velocity ratio is the number of strings that you have there. For Archimedean pullings, you have n strings and n pulleys, which means the same number of strings is equal to the same number of pulleys. If you have 5 strings, you have 5 pulleys. And velocity ratio is 2 times 2 raised to the power of n, where n is the number of strings. For differential or Weston pulleys, the moving wheel and the fixed wheel pulley, it has the moving part and the fixed part. The velocity ratio is 2 times the distance over arrow minus arrow, the bigger distance or the external radius over the internal radius. Now let's see more under pulleys. Pulleys can be fixed or movable. For fixed pulley, the load is connected to one end of a string passing over the pulley, and the effort is applied at the other end. This is what you should know about a fixed pulley, as you can see here. And for a single fixed pulley, the velocity ratio is 1. Mechanical advantage is lesser than 1. But for a pulley where there is no friction, then the mechanical advantage is equals 1, which is equals velocity ratio. If there is no friction in machines, the velocity ratio will be the same thing as the mechanical advantage, and the efficiency will therefore be 100%. Friction is the sole reason efficiency of machines is not equals 100%. And for a movable pulley, the load is attached to a movable pulley with one end fixed to the string and the other end is hooked. So the effort is applied at the other end of the string. For wheel and axle, gel wheels, Velocity ratio is velocity of the larger wheel divided by velocity of the smaller wheel, which is equals the number of teeth in driven gear over the number of teeth in driving gear. So this is for wheels, and also this is for gear system, gear wheels. And for screws, velocity ratio is 2 pi r over p or 2 pi l over p. P is the pitch and r is the radius. Meanwhile, hydraulic press is a simple machine where the effort is applied through a small area and the load is raised over a large area. So these are basic things you should know when it comes to simple machines. Now let's look at one or two questions to solidify our knowledge of machines. Weight W is equals 120 Newton. This is equals mg. Is placed on a plane inclined at an angle of 30 degrees to the horizontal. My students should be happy seeing questions like this. Inclined plane like this at an angle 30 degrees to the horizontal. So this particle weighs 120 Newton. Is placed here. If the plane has an efficiency of 60%, efficiency is equals 60%. What is the force required to push the weight uniformly up there? What is the force required to push the weight uniformly up there? The force required to push the weight is simply the effort. That is the force you need to push the weight, which means we are asked to look for effort. Effort is the question. Now, this is an inclined plane. What did I tell you about inclined planes? For inclined plane, velocity ratio is 1 over sine theta. And since theta is 30 degrees, velocity ratio is 1 over sine 30 degrees. Sine 30 degrees is 1 over 2, that is 0.5. So, velocity ratio is 1 divided by 1 over 2. This is 1 divided by 1 over 2. This is 1 times 2 over 1, that is 2. So, the velocity ratio is 2. And the efficiency is 60%. Meanwhile, we are looking for effort. Mechanical advantage is load over effort. So, if we can get the mechanical advantage from the info given, we should be able to arrive at the effort. But let's just see what we can do. Since we have the load is 120 Newton. So, load is equals 120 Newton. This will work for us. Efficiency is equals mechanical advantage over velocity ratio. Efficiency is 60%. So 60 over 100 is equals mechanical advantage over 2, since the velocity ratio is 2. Cross multiplying, mechanical advantage is equals 60 times 2 over 100. This is 120 over 100. So 12 divided by 2 is 6. 10 divided by 2 is 5. This is 6 over 5. That should give you 1, remainder 1. So let's put the remainder up here. If we add imaginary 0 to the remainder, that will give you 10. So 10 divided by 5 is 2. So this is 0.2. Therefore, 6 divided by 5 is 1.2. 1.2 is the mechanical advantage. So, mechanical advantage 1.2 is equals load 120 Newton over effort, which we are looking for. Effort is therefore 120 over 1.2. And that will simply give you what now? 100 Newton. Option C is the correct. Here it says, if a heavy barrel is rolled up a plane inclined at 30 degrees to the horizontal, the velocity ratio will be dash. For an inclined plane, velocity ratio is 1 over sine theta. Sine theta Theta is 30 degrees. So 1 over sine 30 degrees is 1 over 0.5. That is 2. So option D is the correct option. No need to even solve. The pitch of a screw jack is P is equals 0.45 centimeter. And the arm is 60 centimeter long. So the length of the arm or radius is 60 centimeter. If the efficiency of the jack is 75 pi percent, if that is what I'm seeing, efficiency equals 75 pi percent. Calculate the mechanical advantage. Calculate the mechanical advantage. So MA is equals question. This is under what? Screw system. Remember, I told you that for a screw jack or a screw system, the velocity ratio is equals 2 pi r over p or 2 pi l over p. But I told you that pitch, p is the pitch, l or r is the distance, length, or the radius, or the arm length. If this is true, velocity ratio would therefore be 2 pi times L, 2 pi times 60 over pitch, 0.45. This is the velocity ratio, and that will give you 120 pi over 0.45. Since the efficiency is in terms of pi, no need to break down pi. Solve with pi so that they can possibly cancel in the future. Now, efficiency 75 over 100, 75 pi over 100 is equals mechanical advantage over velocity ratio. Is equals mechanical advantage divided by velocity ratio, 120 pi over 0.45. Mechanical advantage is efficiency over velocity ratio. So velocity ratio is 120 pi over 0.45. This will give you 200 if solved correctly. This is your answer for mechanical advantage. And the next question says, a machine is used to lift a load of 20 Newton through a height of 10 meter. So load is equals 20 Newton. Height, which is the load distance is equals 10 meter. Force load distance is 10 meters. If the efficiency of the machine is 40%, efficiency is equals 40%. How much work is done? Work is equals question. How much work is done? Remember, I told you that efficiency is work done on the load over work done by the effort. So efficiency is equals work done on the load is force on the load times the distance on the load. So work done on the load is force times distance, or the load times load distance. Load times load distance is work done on the load. Everything divided by work done by the effort. Efficiency is 40%. 40 over 100 is equals force times distance, which is work done on the load or by the load, is 20 times 10 over work done by the effort. Now, 40 over 100 is 0.4. 20 times 10 is 200. So work done by the effort is 200 over 0.4. That is the work done by the effort, and it is 500 joules. Ladies and gentlemen, nothing much to see there. That is the correct option. So with this, I will stop answering questions. Thanks for watching. Your one and only teacher from the future. I hope you found this class interesting. Feel free to check out the playlist for more amazing videos. And don't fail to install the Flash Learners application right now for notes, videos, and questions to meet all your needs. Subscribe to this channel so you don't miss out any of my sweet videos. See you in the next episode. Don't forget to tell everyone around about the flash the Bye.